Hello. So this is a review for Unit 3, Topic 1, Formative Assessment 3. They're not going to be exactly like it's on the test, but it's similar. What I'm going to try to do in this video is cover all the questions with different numbers, and I will pause in between the questions so that I can have like a list. So if you're confused about how to do something like number 3, it'll be there for you. So try this. Hopefully it makes sense. All right, so the first question, we could do this on a, no, I'll do it on this so that I can share with this. All right, so this, just a blank sheet. The first question is that I'm going to ask you is, I'm going to say that the moon has a diameter. And I want this to go away because of course I don't memorize what the diameter of the moon is. The moon has a diameter of, let's say 2,158.8 miles, right? And then I'm going to ask, what is the volume of the moon? Okay, so that's going to be something like that first question. And the first thing that you have to do is, well, we need to know how to find the volume of a moon and realize what shape that is, right? So hopefully you know that the shape of the moon is a sphere, right? That's a three-dimensional circle. So I'm going to just quickly sketch what a circle would be. I mean, you know what a circle is, but here's the moon, right? And I can tell it's the moon, and there is showing that it is round. Pardon me, and I know that my diameter is 2,158.8 miles. All right. So volume. Well, we could look it up. I memorized it. 4/3 pi r cubed. If it's something that you haven't memorized, feel free to look it up, right? We are working on the internet now, so that's going to be it. Sorry if it's really breezy, but I'm not closing the window because otherwise it'd be very hot in here. So volume is 4/3, and I wrote 3/4. 4/3. I can hear the wind. Pi and then r cubed, right? Well, what is the radius? The radius is going to be from the center, so it would more look like from the center to the side, right? And that radius is going to be the same no matter where the circle is, right? So if I'm going along anywhere on the circle, the radius would stay the same. I know that I can't draw it that way, but as well as if you think of it like going around this circle, right? I know it looks that, but it's all about perspective, right? So the radius stays the same on a sphere. This is the diameter, and the radius is, the relationship between the two is that the radius is half the diameter, okay? Because the diameter goes all the way from one side to the other. So we need to find out what half of 2158.8 divided by 2. I meant to put that in decimals, but you know what? Google does it too. 1,079.4. So my radius, I'm just going to do 1,079.4, and I want to cube that. All right, I don't like Google Calculator. I prefer decimals, so, you know, each their own. So we want to do 4/3 times pi times my r cubed. Well, that's going to be 70979.4. I hope I said that right. Cubed. All right. So this is giant. This is in scientific notation. Yours will not be in scientific notation, but that's okay. And we want to, well, it's going to be crazy, and I'm going to copy it so I can show you what this is in case you don't remember scientific notation. And then this is to the 9th power, so I'm going to go like this, and to the 9th. And I'm just going to show you for fun what that means, because that's the answer, right? The volume is this many miles cubed. But if you want the scientific notation, right, what this is 10 to the 9th means that you're going to take this number and move the decimal point over 9 spots. 1, 2, 3, 4, 5, 6, 7, 8, right? And whatever's an empty cup, as I like to call them, you just fill them with a 0. So that means this is an estimate, because that's as far as the calculator went. It's 5, 2, 6, 7, 8, 7, 9, 7, 2, 0, right? So that's, there's your millions, billions. So 5 billion miles cubed. All right, so that's what the first one is asking, is just how to find the volume of a sphere that is a large thing. I picked the moon. The Earth was going to be even bigger, obviously. So there's the volume of the moon. So question 1. Pause. Okay, the next question is going to be about population density. So here's the question. The national, and it was hard to find an actual thing. Not hard, but it took me a minute. The National Museum of African American History and Culture has 105,000 square feet of exhibition space and can see an average of 9,000 guests per day. Just found this in a random Google search, so hopefully it's true. The National Air and Space Museum, which is the most popular Smithsonian museum, sees approximately 25,000 guests per day. That is the, I took the average, just telling you where the numbers came from. I took the average that they see per year and divided by 365. Now it's not open 365, but we're just averaging. And has 161,145 square feet of exhibition space. Which museum is more densely packed on any given day? So what you have to do with the population density is it's always, you would, when you're saying it, you would say like people per foot or something like that, right? And this is the way I remember what goes on top of the other one, because it's people. We could say people per foot. We could say people per foot, right? So the way that you find out the population density is you divide the number of people by the number of feet, all right? So if for African American history, we have 9,000 people per this many square feet. I heard this place is packed. I really want to go, and that's why I picked that one. So what I would do is I would do 9,000 divided by 105,123. So that's about 0.9. I'm going to round it. I'm going to just say 0.086. So that's approximately 0.086 people per square foot, right? Yikes, my son's watching, I don't know, something with VR goggles on. Okay, now we need the National Air and Space Museum, which sees more, 25,000 people per day on average, 145. I would like to go to both of these museums. I can't wait till the museums open again. Divided by 161,145. So their population density is approximately 0.155. 0.155. So it's approximately 0.155 people per square foot. So that would say who is more densely populated? The Air and Space Museum. All right, so that's something similar to the second question. So yeah, be back. All right, I keep spending way too much time making up these questions because they already exist and I'm trying to not use exactly the same thing. So what we're going to do is we're going to find the volume of an object, and I'm going to draw that object and we're going to figure it out. So if you want to fast forward, that's fine. All right, I didn't want necessarily green, but it happens, so what's going on? All right, so here is my, I don't know, my dollhouse, right? So here it is. Oops, we're going to pretend that this looks nice. This is my problem. I get too caught up in it. Is lime green good? Nope. And then we'll have a roof on this thing, right? So we'll put a roof on it. There we go. Let's do it like that so it looks fine so that you can see it's the roof, and then bam. Oops, nope, that's not what I meant to do, but you know what? I'll move this over here. Um, bam, there, and there, right? So we'll do something like that, and then like that. I'm sorry, and I'm not re-recording because I am on spring break and I'm done with this. Okay, so let's say that this is like, I don't know, 40 inches wide and like 70 inches long. And we'll say the roof is, let's see, I'm going to make my life easier. So I'm going to make it 10 inches high, and then this slant height is like, oh, I don't want to make it up. I can't make it up. There is something. I could figure out the slant height. I'm just not going to make it up. It's not important right now. I'm not using it. And then we'll add some more dimensions to this after. But if I wanted to right now figure out the volume of this dollhouse, what I have to do is I have to use a volume formula, right? And the volume is always big B for the base times your height. Now, you can call whatever. You just need, I'm not using words, so I'm gonna back up. Okay, so I want to find the volume of the roof, right? And I see the volume of this roof here is a triangular prism. And triangles, the area of a triangle, which is the base, is going to be 1/2 times my little b base, which is this, times my height. And the height of that, well, that in this case, the height is like how long it is, right? Because my base is a triangle, so then this part here is my height. So let's see what I can erase. Okay, so my height here is going to be another, so the height 1, height 2. I know it's annoying, but I don't want you to get confused, and I'm confusing you more. So 1/2, my base. All right, so this is my base, but I don't have a number here. There it is. So 1/2 40 times the height of this is 10 times this height here, which is 70. Okay, that's the volume of my roof. All right, so 1/2 40 is 20 times 10 is 200 times 70 will be 14, and then that's 200, and then an extra 0. So 14,000 square inches. We're going to call it inches. I didn't write inches, but that's what I'm going to call it. Inches cubed, not square. It's three-dimensional, right? We did base times height, so that's 3D. Okay, so that is my roof. No, I'm just kidding. The roof is there. All right. And then if I want to do the volume of like the house, it's still big B for area of base times height. Now, it doesn't matter which one we do here. Oops, I forgot to do one because I forgot this side. I don't know how tall it is. So I'm going to say that it is 15. This is not drawn to scale. Never trust drawing. Okay, so I can do my volume of the base. So my base in this case is 40 times 15, right? 40 times 15 times my length of 70. All right. So I don't want to do that in my head. So 40 times 15 times 70 is 4,200. I should have been able to do it in my head, but you know what? It doesn't matter. Volume of a house is 42,000. Okay. So if I want the volume of the house, of the dollhouse, the whole thing, what would I do? Well, I would add them together. So I'm going to have 14,000 plus 42,000, and that one is going to be 56,000 inches cubed. Okay? So if someone was making this dollhouse and they wanted to cut out a cylinder for whatever reason, and my cylinder is going to be like, I don't know, like they were going to have like a thing right here, and we're going to pretend it's a circle. Well, it is a circle. And we're going to say that this, and then, oh, some video games are going on. Sorry, it's going on in your house too. Don't judge. Although we could turn it down a slight bit. That'll happen in a minute. Okay, so say that this cylinder got cut out. right, for whatever reason. So there's a big, you know, they live in a tube. I don't know, maybe it's a hamster house, you know, like those hamster things, and this is just where they are. So right now the volume may be 56,000 square inches, but then we cut out, so that's like if it was solid, and this is if I drill out a big hole, and we're going to say that this radius here is, I want it to be 4, because then we have 8 across. No, let's do 5, because I want to make my thing. So it's 10 across. Oops, not drawn to scale. I'm going to keep saying that, not drawn to scale. So let's make that, since it's not drawn to scale anyways, let's make it 8. All right, so I need to figure out how much volume I just took out of that house. So right now it was a solid wooden block or whatever it was, and now I drilled out this. The volume of a cylinder is still the same thing. Area of the base, big B, times your height. So your volume, the base is a circle. The area of circle is pi r squared times my height. Okay, so in this one, I made my radius 8. So it's going to be pi times 8 squared times my height, which is still 70. All right, calculator, pi times 8 squared, which is 64, but I'm going to put it in as 8 squared times 70, and we'll see how big this is. All right, so a little more than the volume of the roof, and that's fine. We'll call that 14,074, and we'll do 0.34. So 14,000, and I already forget, 74.34, 74.34, 074.34. So that's the volume of that cylinder. So if it was a solid wooden block and I just carved that out, how would I figure out how much volume of wood I have? How much volume of wood exists in this? It's become a hamster house. Okay. So what I would do is I would subtract, right? Because if you drilled it out, you're taking that wood out, right? So I'm going to subtract 14,004.34, and I'm going to let the wonderful calculator do it. So that's 56,000. Oops, not 56. 56,000 minus your 14,074.34. So the volume of wood for this house would be 141. I don't know. It's a big hamster. I don't know. That's not right. 41. So, and I could have just used subtraction. So 41, 925. Listen, guys, it's technically spring break right now. Inches cubed. Okay. So that would be the volume of the house. Because I did the parts, put them together, and that's the volume of the house. And then I took away the volume of the cylinder. And we'll come back and do a density problem. Okay, we're going to keep the density stuff pretty basic because it is one equation that you need to know. And I'm going to show that to you right now. Density is always mass divided by volume. Now, mass is typically in grams, or that's your mass, and you know that from science class. Weight isn't necessarily mass, because what I weigh on Earth is different from what I weigh on the moon, but I still have the same amount of mass no matter where I am. So what they're going to ask you to do on these ones is like get in between them, right? So like sometimes you'll say like, all right, my mass is 45, my volume is 15. So what's my density? Well, you literally do 45 divided by 15, which is 3. So my density is 3. Other times they'll say, all right, my density is 28, my volume is 13. I'm just making up numbers as I go. How would I figure that out? Well, you still plug it in the same way. So 28 is going to be your mass divided by 13. So to figure that out, what I want to do is I want to multiply both sides by 13. All right, so this crosses out this. So 13 times 28, 13 times 28 is 364. So my mass is 364. Okay, So that's what it is, really just playing with it. And again, I'll just do one more with, and I'm going to do different colors so I can keep on the same page, because density equals mass times volume. Well, if I tell you that my mass is 12 and my density is 4, right, what is my volume? Well, I'm just going to go down to the next. No, I'm going to stay right here. I'm going to move this up, and I'm going to say, all right, well, D is 4. My mass is 12 and divided by some volume. Well, this one's not so terrible because you know 12 divided by 3 is 4. But if you didn't know, what you could do is multiply both sides by V, because that'll cancel that out. So what that says is that 4V equals 12, and divide both things by 4, and V equals 3. All right, so that's your density. Those are what we're looking for here. Yes, the questions have a little bit more decimals and things like that. Remember that if there's more density, then that's going to be something that should be like heavier for its size, right? And we are all talking about Earth here, so we don't have to worry so much about like mass, but just know that mass is the amount of stuff, not as much of how much that stuff weighs. But if something has more mass and smaller volume, it's going to seem heavier. I hope that that's true because I just said it, and this is on YouTube, but you guys are watching it. All right, guys. So what I'm saying now is like that's going to be, maybe that's enough for you to take this test and go with it. If you're still confused, come to your office hours, which you'll be emailed about, and we'll chat and we'll talk and we'll figure this stuff out. But if you already know how to do it, cool, do it. Little, you know, ingenuity, a little bit of effort will get you there, because I know that you guys are smart. You just don't always like to do, you know, geometry. Some of you love it, so I don't want to downplay it. I love geometry, so we can talk about it on this week. It'll be Wednesday and Thursday will be our days, and if you can come in at any period, like whether it's 4th or 6th, that's fine. Just don't skip another class to come to my class. And if you do have issues with conflicting issues with like, I can't show up to my period because another class is meeting, like let me know about that. If it's that you're working or doing other things, also let me know, because if we need to, we can hop on a Zoom call and do this. All right, so I'll have to figure this out. I hope you guys are good and have a good weekend. This is your spring break. Miss you. Bye.